So when I teach this in my classes, I'll often have students come up to me after class and say, "Hey, why are you doing this whole test point thing?" I was taught, usually in high school, that you can tell where you should shade based on the inequality, right? And the rule usually goes something like this: if the inequality is less than or equal to, then you shade below the line. Or if the inequality is greater than or equal to, you shade above the line. Setting aside the fact that above and below can get a little dubious, right? There's a problem with this. It doesn't always work, right? Because if you're looking at this inequality here, for example, you could reasonably think that you're supposed to shade below the line because it's less than or equal to, right? But let's see what happens if I go through the method here, right? I'm going to start by turning this into an equation and solving it for y, right, to get my boundary line. Negative 3y equals x plus 6. Y is negative 1/3 x minus 2. So my y-intercept is down here. My slope is negative 1/3, so I'm going to go down 1/3, and I'm going to do this several times because my drawing ability is massively sketchy, and lots of points helps me to get a clean line. All right, so I'm going to draw this line here. There's my boundary. Now, again, if you're looking at this and you're kind of applying this method, you're thinking you're going to shade below the line. So you're thinking you're going to shade down here. But watch what happens when I pick my test point. All right, I'm going to use the origin. So I always do when I can, or the origin's not on the boundary, so that's a safe point to use. And if I put that into the equation, into the inequality, negative 0 minus 3 times 0, that left side is 0, and look at that. That's true. 0 is less than or equal to 6. So here, my solution is not the region below the line, it's the region up here above the line. So what happened? Why did this method you were taught in high school, a lot of some students were taught in high school, why did it not work? Well, because there's an assumption to the method that I don't know if it's not taught sometimes, or if students just forget it, or what. But watch what happens if I take this inequality, right? I'm going to go back to the original inequality. Watch what happens if I try to solve this for y. Right? I'm going to follow the same sequence of steps, right? I'll move the x over, and here's where the trouble is about to start. I got to divide both sides by negative 3, which is a perfectly fair operation. This becomes y, negative 1/3 x, minus 2. But because I divided by a negative number, I have to reverse the inequality. So now it goes from a less than or equal to a greater than or equal. And yeah, okay, now if you're trying to apply the rule, right, that says shade above the line, right? So I'm just sketchy about the rule, right? Because it doesn't always. It depends on the context. It depends on what your inequality looks like. If it's solved for y, and we've resolved any problems with dividing by a negative number, then yeah, okay, we can talk about it. Right? But if your equation isn't solved for y and you try to base your answer off of the original, yeah, you can get into trouble, right? In particular, especially if there's negative numbers floating around in there.